Today we're going to learn all about commercial spaceflight.
There are a lot of companies working really hard to get people and payloads into space.
And the one thing they all need is a rocket engine.
There are three main types of rocket engines.
There is a liquid rocket engine and there is a hybrid rocket engine.
We're also going to learn about solid-fueled engines, which once you light them, they are off.
Like a firecracker.
This is STEM in 30. Hi, I'm Marty.
And I'm Beth, and we are coming to you from Key Middle School in Springfield, Virginia.
You might be wondering, why are we at a school and not back at the National Air and Space Museum? Well, there's a really good reason.
They won't let us set things on fire or make a mess at the museum.
But today, we're going to do both.
As you saw, we use solid fuel to make those little explosions.
A great example of a solid rocket fuel are the solid rocket boosters on the space shuttle. Once they were lit, there was no turning back. It was off to the races.
You can make your own rocket using solid rocket fuel by joining a model rocket club.
We're going to put resources on the Facebook page for STEM in 30 where you can learn all about how to get involved in model rocketry near you.
And if you have a successful launch, we would love to see it. Send us a video or a photograph.
We're going to be learning all about rockets today, but first let's learn a little bit more about commercial spaceflight.
I am joined by Scott Tingle, NASA astronaut. You spent 168 days in space, correct?
I did.
How did you get from the Earth to the International Space Station?
Well, I took the Russian Soyuz, and it's a wonderful system. It's an old design, but they've been constantly upgrading it over the decades. Very reliable, very robust, and they've been doing it a long time. Very safe system, very quick, 8.5 minutes up to low Earth orbit, and just a few hours to undock and separate, and then return to Earth. So a really nice system.
We have come up with some new systems that NASA is using. Can you tell us a little bit about those?
Sure. We're into our commercial crew effort, and we should start seeing those vehicles fly here soon. We're very excited to be able to launch off of American soil to the International Space Station. We have the SpaceX Dragon that's getting ready to do their test flights and then have a crewed test flight up to the space station. And we also have the Boeing vehicle that should be testing right about the same time frame, and again getting our folks up to the space station. We're very, very excited to see this happen.
How will those vehicles be the same or different than the shuttle and the Soyuz?
Well, the shuttle was a magnificent flying machine, like we all know. It was beautiful to watch it take off and launch and then come back and land on a runway. The new vehicles will be probably a little bit closer to Soyuz because they'll be capsules. The Boeing Starliner will launch on top of an Atlas, and then it'll come back and it'll land on land. And the SpaceX Dragon will launch on top of the Falcon 9, and it'll come back and land on water.
Now, I hear that landing in the Soyuz is a little rough.
It can be hard. They have soft landing thrusters, okay, but don't let that word fool you. There's a reason why we've been flying Soyuz for so long and why we've relied on them when we had to stop flying our vehicle. And their system is very simple and very robust. And so some of the niceties they traded away so that they could have a very simple and robust system. And they do. They land in the desert, and it lands a little bit hard. But it could also survive a landing without the soft landing thrusters as well, because it's got some backup mechanisms in the seats that would absorb the shock of landing. But the parachutes come out, you're slowed down, things are very quiet, and about a meter above the ground, the soft landing thrusters fire, and then you hit the ground, and it's like a small controlled car crash. A lot of dust, a lot of dirt, and you miraculously you're there, and and it worked just fine.
How are the commercial spaceflight vehicles going to land?
I hope it's a more comfortable landing, and you know, the American design philosophy a little bit different than Russian design philosophy. Our vehicles will probably not be as tough as the Russian vehicles, so I do expect the landing to be a little bit softer.
Okay, thank you so much for telling us about commercial spaceflight. We appreciate it. Thank you. All right, touch the red one. Now reach out and get the yellow. How about the purple? That was pretty easy. Well, when engineers design the insides of spacecraft, they have to consider the astronaut, and that means sometimes they're floating.
Or laying on their backs. Astronauts spend a lot of time on their back when they're in the rocket just before launch. Can you reach the blue one? How about the green one? Yellow? Is this very comfortable? No, not really. Not so much. Beth got an opportunity to talk to a Boeing engineer about how they think about the human elements when designing spacecraft.
I am joined now by Selena Dopart. Thank you so much for joining us today.
Absolutely, it's a pleasure to be here.
I've read that you pretend to be an astronaut every day. What do you mean by that?
So I work on the commercial crew program for Boeing. I work on the CST-100 Starliner, which is going to be the next spacecraft to take American astronauts from American soil to the International Space Station. It's been many years since we've done that, since 2011, the last space shuttle mission. They actually just announced the astronauts who will be flying on our first crewed flight test and then the first mission. So most of them are NASA astronauts. We do have one Boeing astronaut who is a retired NASA astronaut, so he's got tons of experience. He was actually the commander of the last shuttle spaceflight. So I have one of the coolest jobs besides actually being an astronaut. So I do aerospace human factors for the Starliner, which basically means anything that the astronaut is going to touch or interact with or need to sit in or breathe or think about in any given mission, I help design and train for the astronauts to operate. So part of that is verification testing. We need to make sure that our spacecraft and everything in it meets the requirements that NASA gave us so that we can complete their missions. And so we do testing in a full-size mock-up of our spacecraft. And it actually looks pretty similar to some of these ones behind us. We use a capsule design, so they look pretty familiar. And we've got a full-size mock-up that we can go into and practice doing different procedures that the astronauts will do. So I help define those procedures and train those procedures so that the astronauts and different test subjects that we get can come in and give us feedback on how our design actually works.
How important is it to have these private companies working with NASA to develop these capsules in this next generation?
Boeing has been involved in nearly every endeavor to get astronauts out of Earth's atmosphere from American soil. So these capsules that you see behind us, Boeing and its heritage companies were part of building these. Boeing does have a lot of heritage with NASA already, but this time we are building our own spacecraft, right? We want spaceflight to be something that the everyday American can say, maybe one day this will be something that I can do. And that's kind of why we call it the Starliner. We have the Boeing 787, the Dreamliner.
Right.
So we've got the Starliner. We're not just looking to have NASA as our only customer. Eventually, once we become operational and we prove ourselves with NASA as our customer, we're going to look to expand into more industries, education, research, science, that sort of thing. So, and space tourism. So really, we do hope to transition space and be a part of that transition to opening it up to more people.
So what you're telling me is that I may be riding on a Starliner at some point.
You absolutely could.
Thank you so much for joining us today.
Yeah, absolutely.
To get rockets off the ground, you have to have a chemical reaction.
And a chemical reaction involves atoms, that smallest building block of matter. Atoms are bonded, chemically bonded. They stick together, and a chemical reaction makes those bonds break apart, and those atoms move around, and they form something new. Should we try it?
Sure. All right. This is going to be a chemical reaction. We have what in here?
Hydrogen peroxide.
And then we need a little
dish soap.
put some dish soap in there, and then I'm going to make it colorful and put
I love food coloring.
I put a little color on this side.
Ooh, not just down the middle, but on the sides there.
All
so
right,
we're
now you've got some yeast.
Got some yeast we've mixed
Let's-
with water.
See what happens.
All right. Nice. Looks like a volcano going off there.
Another fuel source that we haven't talked about yet is liquid rocket fuel, and we're going to talk to curator Mike Neufeld about Robert Goddard and his experiments with liquid fuel.
Check it out.
On March 16, 1926, Robert Goddard launched the world's first liquid propellant rocket. It looked somewhat like this thing to the right of me, the hoop skirt rocket from 1928-29. It was smaller and it was on a launch frame. And then he was out in the snowy field outside Worcester, Massachusetts. It flew up about 16 feet and landed about 40 feet away. So it didn't go very far and it didn't do very much and then crashed. But it was the first time in the world anyone had launched a liquid propellant rocket. The benefits of liquid rocket fuel are twofold. First, higher chemical energy than any solid fuel, and second, controllability, the ability to turn it on and off at will. Yeah, Robert Goddard was the first person in the world to develop a liquid fuel rocket, but his real influence was inspiring people to believe in space travel, inspiring people to believe that rockets were the way to go into space.
We've taken a look at solid rocket fuel. We have taken a look at liquid rocket fuel. We've taken a look at chemical reactions. Now we're going to take a look at a hybrid system.
And to help us learn about that, we brought Tom Lastman, a curator from the National Air and Space Museum. Tom, thanks for joining us.
Hi, well, I'm delighted to be here.
Tom, do you want to tell us what is a hybrid rocket and why is that important?
Okay, so a hybrid rocket is a merger essentially of two separate technologies, a liquid propellant rocket engine and a solid propellant rocket engine. So liquid propellant rocket engines have a number of advantages. One is you could turn them on and off when you're in space, and two, you can throttle it like pushing on a gas pedal in your car. The problem with liquid propellant engines is they are very expensive to operate. They have volatile fuels. They require a lot of maintenance and skill to fuel them and to operate them. Solid propellant rocket engines, the advantage there is that they're very cheap, they're reliable, they're very safe, they don't require a lot of maintenance, they can be stored for a long period of time.
The problem, though, is that you cannot turn them
Yes,
off.
the problem with the solid propellant rocket engine is once you light it, it's like a firecracker, it goes. You cannot turn it off. And it cannot be throttled to the extent that a liquid propellant rocket engine can. So that's the disadvantage.
So hybrid's kind of like the best of both worlds.
It is.
Awesome. Should
All
we
right.
try something out?
Sure,
All right,
let's
safety first.
Right.
Goggles.
Safety, yes.
We have some yeast in here, and we're going to mix some hydrogen peroxide. Yeah, that's going to make some release the oxygen here. So get this started, and we'll get this bubbling.
Stand back here.
All right. And so we got that bubbling. We've got a top to the jar with a little hole in it. And we're going to put our ZD rocket on top. And Marty, we're going to need a little heat here. Okay, ready? Let's see what happens.
Like I like to do, bring the heat.
The liquid mixes with the solid. Oxygen is drawn up through the ZD, and it burns the fuel. And so you'll see some flame coming out of the top, which would be the equivalent of thrust in a rocket engine.
Now it's your all's turn to try it out.
Tom, tell us why a hybrid engine is better for commercial spaceflight than liquid or solid fuel.
The reason for commercial spaceflight, this is a private sector initiative. Richard Branson, the owner of Virgin Galactic, has created this technology to take tourists into space. And the reason that the hybrid rocket motor is used because it is the cheapest way to get humans into space for, basically it's space tourism. And his idea is to bring down the cost so that as many people can do it as possible. And if you're in the private sector, you need to make money. Cost is a big deal, and this is the most efficient way to do it right now.
Sir Richard Branson recently gave the National Air and Space Museum Rocket Motor 2. Check this out.
Thank you for being with us here today for an exciting announcement about a new artifact joining our collection. This new artifact from our friends at Virgin Galactic joins an esteemed collection. We are excited to accept into our collection Rocket Motor 2, the hybrid engine that powered VSS Unity on the flight. This was the first crewed commercial suborbital spaceflight since Spaceship One retired to its home here at Air and Space. And it is the first step in achieving Virgin Galactic and Sir Richard's goal of offering commercial flight on Spaceship Two. We are grateful to have the team involved in this milestone here with us today to donate an artifact that will help us tell the story of this moment in aerospace history.
Today, we have 4 distinguished partners, members of this team with us. Where do you see commercial spaceflight going?
We are right at that inflection point cusp, right? We're going to start to see what was one test flight suddenly become 5 or 6 or 10, and then commercial flights, and they'll go from 1 to 5 to 6 to 5,000 to hundreds of thousands, right? Our future here is to open space to everybody and let everybody have a chance to go experience space, see the Earth from above. And the more people that see the Earth from above, the more change you can make on Earth, right? You bring space back home with you. And to be able to give people that perspective in a much broader swath than we ever have before, I think that's the future.
I'm also thrilled about that we are actually bringing more space technology back on Earth as well, and how we can empower and improve the lives of everyone across the globe.
What was the most challenging part of reaching this achievement?
I mean, developing the world's most powerful hybrid rocket motor was certainly a challenge. You know, we've been working on that for so many years, and to get that perfected to a point where we had, you know, a great engine that was giving us the performance we needed on the ground, and we were doing that safely and with the margins that we wanted to see on the ground before we brought humans into the picture and started doing test flights.
Safety is critical.
Yes, I mean, it is the most important part. Without that, you know, we don't fly.
Again, I just want to applaud and emphasize the importance of the tenacity and the dedication and the passion for opening up space to all of us. And seeing these achievements and reaching these milestones is absolutely critical. And bringing children to events like this and opening up the doors to young people to be part of whether it's an intern program or allowing them to come on test flights and sites, it's inspiring the next generation.
You going to go to space one day?
Yeah.
Tom, we've got a few minutes left. You ready to take some questions?
Absolutely.
All
Fire
right,
away.
let's start with you.
What is the best type of fuel in terms of speed?
It really depends on what the purpose of the mission is. If you're planning to, for example, to go to the moon, you need to have a fuel and a rocket that's going to enable you to escape the Earth's gravitational pull and give you enough speed to get all the way to the moon. If you're just planning to go into low Earth orbit, for example, for a satellite, it's going to be different because you just need a vehicle that's going to get you up into orbit to be able to launch the satellite. So it really depends on what the mission. It also depends on the rocket, the size, the capability, and questions like that.
Okay. All right, go ahead.
I'm in 8th grade. Can I go to space?
That's a really good question. You might be able to. Now that Virgin Galactic has launched Spaceship Two, which is going to be the first crewed vehicle to carry paying space tourists into space, you might be able to, it's very likely that you will be able to do that.
Start saving money.
Yeah, start saving money. It's expensive. I think Virgin Galactic for its initial flights is looking to charge about $250,000, about $250,000 a pop. The idea, though, is that as they build more spacecraft and the price of going into space continues to drop, those ticket prices will come down.
And when you go into space, we want you to come back and see us on STEM in 30.
Yes.
Okay.
Tell us all about it.
All right, our next question.
What type of engine did the space shuttle use?
So the space shuttle uses 2 different types of propulsion systems. So if you think it visually about what the space shuttle looks like when it's on a launch pad, the orbiter is like this, and in front of it is this big external tank. There are 2 solid rocket boosters, one on each side. So in the back of the orbiter are three liquid fuel rocket engines. The liquid hydrogen fuel and the liquid oxygen oxidizer are in that external tank, and those engines burn for about 8 minutes. And on the sides are the solid fuel booster rockets, and they're essentially just that. They help boost the shuttle into Earth orbit. They burn for about 2 and 2.5 minutes, and once they're done burning, they drop off of the external tank and fall back into the ocean, where they are reused again. They're reusable solid rocket boosters. And the shuttle flies on for about another 6 minutes or so into low Earth orbit. One of the really interesting things, and if you go and look at a video of the space shuttle launching, you'll always see that the engines on the back of the orbiter ignite first. And you'll hear mission control yell.
We have main engines start.
See them burn for a few seconds, and then the booster rockets light, and then the whole thing goes. The reason they ignite the liquid fuel engines on the back of the orbiter first is because if there's a problem with those engines, or the telemetry that's going back to mission control indicates that there's a problem with the engines, they can be shut off. Because once the boosters light, you're done, and it's going to go. And if there's a problem with the engines on the back of the orbiter, once those boosters light, well, they're going to have to figure out what they're going to do when the whole system is flying. So orbiter engines always ignite first to make sure that everything is okay, and then they light the boosters.
Awesome. All right, we've got another question.
Did jets ever use rocket engines?
They were used going all the way back to the 1940s into the 1950s. And the idea was for big aircraft, like the Air Force used them on their big strategic bombers, like the B-47, which entered service in the late 1940s. So the B-47, for example, it has jet engines on it, but it has these little rocket engines on the wings also to help get it off the ground. They just burn for a very short time, and they're just to help these big lumbering aircraft get off the ground quickly.
But a jet engine is not a rocket engine.
The jet engine is not a rocket engine.
Tom, why is it important for the National Air and Space Museum to have commercial spaceflight represented in the museum?
So this is really important because we're at the stage in spaceflight where now the commercial sector, the private sector, is beginning to take a much greater role in the development of space technology. Traditionally, this was a role that was carried by the federal government through the National Aeronautics and Space Administration. NASA still has a big role in spaceflight, but now we're beginning to see private companies move into that field on a much larger scale. You have firms like SpaceX, you have firms like Blue Origin, you have firms like Virgin Galactic that are now getting on the cusp of sending tourists into space. The commercial sector is a very vibrant and robust industry, and so we want to have that as part of our museum displays because it's an important story to tell.
And they are also working a lot with NASA.
And they are working very closely with NASA, yes. I want to emphasize that NASA is very much involved with the private industry, and it's very much a public-private partnership. So it's very exciting.
And we're very excited about the direction that the museum is going in.
Yes.
We truly think it will ignite tomorrow.
It begins with a spark.
Hey, Jackie, wait for me.
The passion for air and space.
Why don't you take it? It'll look better on you anyway.
Hey, Jackie, remember her?
That passion can grow. Lighting the way forward for a lifetime. And now, with the monumental transformation of the Smithsonian's National Air and Space Museum, this place that has ignited generations of imaginations will be completely reimagined, inside and out. all so this museum can be even more of what it's always been. A place that gives life to a remarkable past and gives rise to the people who will make history tomorrow. Join us in the mission to transform the National Air and Space Museum. Together, we'll ignite tomorrow.
Tom, thanks so much for joining
Oh,
us
you're welcome. It's
and
my pleasure.
helping with all this today.
It's fun. I loved it. Thank you.
Awesome. Well, NASA has already selected some of the commercial spaceflight astronauts.
And Marty got a chance to talk to Victor Glover, who's going to be one of those astronauts who goes up commercially. Check this out.
Introducing NASA astronaut Victor Glover.
I'm joined by NASA astronaut and naval aviator Victor Glover. Thank you so much for talking with us today.
Yeah, glad to be here, Marty.
You guys do a lot of training, particularly training underwater for walking in space. What is that training like?
Oh, it's amazing. You've got lots of people there to make sure that things are done safely. To put those two people in the suits, you may have 25 to 30 people there. And to put that on, you're really wearing a spacecraft. When you're outside of the space station, you're in a personalized spacecraft. And putting that on can require the help of teammates. So there's a lot of folks there to help make sure that things are done safely. And then you go to work. You start to train to repair things, to use the tools, and to work together and to communicate with your teammates. It's amazing training. Crew members that are experienced talk to us new guys and let us know what things are really like and give us some things to choose from so we understand what it's like.
Is that an important part of the training, is talking to people that have been there and done that?
Absolutely. You know, the folks that train us, they've got the great degrees, they've been at NASA for a very long time, but there's only a small cadre of folks that have actually been there and taken all of that training and put it into practice. And so that's the folks that have been in our office for a while. And so we lean very heavily on their experience.
Awesome. Well, thank you so much for talking with us today.
My pleasure, Marty.
That's all the time we have for today. I want to thank our friends from Key Middle School. Woo! They did a great job with helping us out with our experiments.
We'd also like to thank Tom Lastman for joining us and helping out with the noodle engines.
We want to remind you to watch our mission debrief.
We'll be bringing in an expert on commercial spaceflight to answer your questions. Send them our way. Facebook, Twitter, email, even a carrier pigeon. As long as it gets to the museum on time, we would be happy to answer that question.
We also want to thank the Gertrude E. Skelly Charitable Foundation for sponsoring our show today.
And don't forget, commercial spaceflight is here. Maybe you'll be heading into space soon. Thanks
for watching. Ryan never tells me to go.
I can feel that. Woo! Do I still have eyebrows?
That was nice and warm.
Woo!
That's all the time we have for today. We want to thank these great students. We've got that was really crappy. Let's